Great questions. Well, first, those people who talk about the all-in argument, they're the ones who are not providing all the information, because when I hear this argument as well, and for example, they'll always say, when they're trying to say nuclear should be, when you're comparing nuclear with wind, you have to add batteries to the wind, for example. Well, nuclear needs batteries too. I mean, nuclear does not meet the demand for electricity. Nuclear, for example, is baseload power in North America. And there's only 2 countries in the world where it's not baseload power, but even then it doesn't meet the demand. It kind of ramps up a little bit, but doesn't meet the demand. So you do need storage with nuclear power, and that storage today, or peaking, you need additional peaking power, and that storage is often natural gas. But that natural gas that you're adding, these are peaker plants. That peaker, like conventional natural gas, which is run as baseload, the cost of that natural gas is on the order of 6 or 7 cents a kilowatt hour. Well, a peaking natural gas plant is on the order of 18 cents a kilowatt hour. So nuclear has to be added with that 18 cents a kilowatt hour natural gas plant, or you can add it with the hydropower. So there really is both wind and solar. Sure, they need to be added with storage to get the overall cost of energy, but so does nuclear. But new nuclear, if we're talking about new nuclear, I mean, as I mentioned, it's 7 to 8 times the cost per unit energy as new wind or solar. That's per unit energy. So when new solar plus storage in California is now like, I mean, the solar alone is on the order of 3 cents a kilowatt hour, just for the solar. Same with wind, new onshore wind in the United States. The solar plus storage, it goes up to about 4 or 5 cents a kilowatt hour. But new natural gas, just the natural gas alone for conventional natural gas is 7 cents a kilowatt hour. So wind and solar are, without storage, are half the cost of new natural gas. And you can find these numbers in Lazard. They do the levelized cost of energy. When you add storage, you're adding from actual PPAs, solar and storage or wind and storage, you're seeing, on the order of 4 or 5 cents a kilowatt hour. But it all depends on how much storage you put in. Now, so that's based on power purchase agreement. But like when we do modeling, I mean, the overall, the cost of energy when I actually combine wind, because we don't do modeling of just wind or just solar alone, we do modeling of the whole system. And the overall levelized cost of energy of a wind, water, solar system, the cost per unit energy is similar, maybe in 2050, maybe 10% less than a fossil fuel system. But that's not the cost you really want to look at. You want to look at the annual cost of energy, because in a wind, water, solar system, in Canada, you're using 62% less energy. So even if the cost per unit energy is the same, the overall annual cost people are paying is 62% lower, because you're using much less energy. Because, yeah, if you're driving an electric vehicle, that's much cheaper than driving a gasoline vehicle. And same thing with driving or heating water, using burning gas for a water heater instead of a heat pump water heater, you'd use 1/4 the energy. So I'd say on the first issue, you have to call their bluff and say, look, you need to, when you're talking about nuclear does not meet the peaking power. Doesn't meet the peaks in demand, and you need storage as well. And the actual cost per unit energy of that nuclear is 7 to 8 times higher now than new wind or solar. So any way you slice, it's still going to be cheaper, solar with storage. The other question is resistance to growth. I guess this is really a question of what people want. Do they want to solve the problem or not? Do we want clean air? Do we want clean water? Do we want to reduce climate problems? Do we want energy security? Do we want more jobs? I mean, overall, worldwide, there are far more renewable energy jobs created than fossil fuel jobs lost if we transition. And so there's the jobs argument, there's the health argument, there's the overall cost argument. Cost of energy goes down significantly, the annual cost, because when we electrify everything. So I think this is really information. The key is to educate the public about the benefits of a transition. And I think that's really critical, because most people, if they don't, if they're not well informed about this, yeah, it's easy for the fossil fuel industry to convince them that, this is going to increase their costs, going to cause all sorts of people say, oh, it's going to cause all sorts of noise problems, or throw ice onto their house or something. Wind turbines will throw ice, and cause damage. I mean, they'll come up with all sorts of arguments. But it's really an education issue, I think.